Since the beginning of time, circles have been at the center of the universe, literally.
Take the sun for example, the brightest star. What about the moon, the world's first waterbender, or even the earth to say?
Humanity has always been concerned with the circle. What makes it so special? It has no edges, cornerless, follows a cycle, is a never-ending love story.
What if we wanted to label a position on the circumference of a circle? How do we label this direction? Is this direction or segment even real?
That's where degrees and radians come in, as units of measure. Our story starts with a very simple question. Why do we use radians over degrees, and what are the implications in mathematics? The ancient Babylonians first invented the degrees from their Sagagimisal numeral system, which is of base 60. This is where we get 60 seconds, 60 minutes, and 360 degrees in a circle.
Why 360? Because it is convenient. Does that mean all knowledge exists because it is convenient? Degrees are simple, have 24 divisors, and are divisible by every number from 1 to 10 except 7.
Another theory is that the year has 365 days and the Earth follows a circular pattern in the solar system. The ancient Babylonians noticed this. Thus, the use of degrees is very arbitrary. It could have any number like 120 or 680, and it doesn't have to be 360.
So why are we taught degrees until we are hit by SL Math? It's not because IB hates us, but because in the mathematical world, radians are even more convenient than degrees. Here are some reasons why.
1. Radians are ratios, and ratios make everything so much simpler. When working with complex math equations, you want things to be as simple as possible and in a way where you can reduce them.
2. They are directly correlated to pi. Here's a circle. Say we are to create a sector. If the arc length of this sector is equivalent to the radius, then the angle of this sector is 1 rad. Mathematicians started filling up the circles with these sectors and soon discovered that they could fit 3-ish sectors in a semicircle. Later they discovered that they could fit pi number of radians in half a circle, meaning that a full circle, is equivalent to 2 pi radians.
3. Radians are also often used in physics or calculus because they have a certain naturalness to them. For example, take trig derivatives. The derivative of sine is cos, and the derivative of cos is negative sine. However, if you use degrees, the derivative of sine is pi over 180 cos, and if you take the derivative of cos in degrees, you get negative pi over 180 sine. And it all looks very ugly.
4. Easiest way to find the length of an arc sector, whereas in degrees you have to convert it and use 1 over 180.
5. The graph of radians also look much more simpler than the graph of degrees, as that one is more stretched out.
6. Euler's formula is much simpler and prettier when used in radians. For example, e to the power of I times theta is equal to cosine theta plus I times sine theta versus e to the power of I times pi times theta divided by 180 is equal to cosine theta plus I sine theta. Finally, why do we use radians over degrees? Because they make life really easy.
But do they really exist? If we discovered radians for convenience, how many other things have we discovered due to convenience?
Are they real? Were they discovered? Were they invented? Why, gee whiz, aren't you glad this video answered why we use radians over degrees instead of these awful questions?
Thanks for watching!
Yay!